Okay, this is our first video on similar triangle proofs. So we've been looking at congruence before. Congruent figures have exactly the same shape and exactly the same size, but similar figures, one figure will be an enlargement or a reduction of the other figure. They'll have the same shape, but not the same size. So two triangles are said to be similar if they have the same shape, but not necessarily the same size. One triangle can be obtained from the other by either an enlargement or a reduction transformation. Now, if two triangles are similar, then the matching sides will be in proportion or in the same ratio. For example, in one triangle, the sides might be double the size of the other triangle, or 3 times bigger than the other triangle, or half the size of the other triangle. And the matching angles are equal. So for the shapes have to be the same shape, but the sizes will be different. One will just be like a photocopy of the other, okay? The symbol that we use for is similar to is this, 3 vertical lines. The 3 horizontal lines are is congruent to, is similar to is the 3 vertical lines. So there are, just like there are 4 tests for congruence, there are also 4 tests for similar triangles. Now, I'm going to draw, I'll just give you an example of 2 similar triangles here. We did similarity last year. For example, this might be 90, this might be 60, this might be 30, for example, okay? And this might be, say, 10, and this might be, I'm just going to put a couple of the sides. This might be 6, for example. Actually, I'll make it bigger. I'll make it 7. So, and then I might draw another triangle over here, same angles. So this is just an example of what similar triangles are. This might be 20, and this might be 14. Now, these 2 triangles have all the same angles. Right angle 60, 30, right angle 60, 30. But if we look at the 10 and the 20, they're corresponding sides because they're opposite the right angle. They're both the hypotenuse, for example. Going from 10 to 20, what did I do? Times 2. And 7 is opposite the 60 degrees and 14 is opposite the 60 degrees. What did I do going from the 7 to the 14? So these 2 triangles are similar. They have the same shape. In other words, all their angles are the same, but their sizes are different. One's an enlargement of the other. Now, there are 4 tests for similar triangles, just like there are 4 tests for congruent triangles. The thing with similar but, you are not to write AA, like whatever they are, you're not to write the letters out. So the tests for congruence are SSS, AAS, SAS, RHS. When it comes to similarity, you are not to write them that way. Okay, and I'll explain why in a minute. Tests for similar triangles. These 4 tests are the minimum amount of information that is needed to prove that 2 triangles are similar. Here is the first test. If 3 sides of one triangle are respectively proportional, you don't have to use the word respectively. If 3 sides of one triangle are proportional to 3 sides of another triangle, then the triangles are similar. Now, we do not write, you're thinking 3 sides, SSS. You don't use SSS. SSS is for 3 sides exactly the same size, not 3 sides in proportion. Let's look here. How would you know which sides to match up with which? 3 is the smallest side in the first triangle. What's the smallest side in this second triangle? So they're matching. See? What about the second, the largest side in the first triangle, the largest? 6 is the biggest. What's the biggest in this one? So girls, we can see that 3 matches with 6. Of course, small side will match with the small one. The biggest will match with the biggest. And the in-between ones are 5 would match with 10. Now, basically, you do not write side, side, side. SSS means that 3 sides in the first one are the same as 3 sides in the second. They're not the same. They're double the size. Do you see that? So the reason when we do a proof, it will be 3 pairs of matching sides are in proportion. That's what we write instead of SSS. We do not write SSS. we write 3 pairs of matching sides are in proportion or in the same ratio. Okay? Next one. So it's like SSS, but girls, if you think basically that similarity is when you enlarge a shape or reduce a shape, isn't it obvious that the sides are going to be either double, triple, half the size originally, a quarter of the original size? Each of the new sides will be related to each of the original sides by some factor, by a scale factor. All right? Test number 2 is 2 sides and included angle, but we don't write it like that. It's like SAS, but we do not write SAS. The second one is, let's have a look here. Can you see the 110-degree angle? So we've got the 110-degree angles. They're both obtuse. Now, there are 2 sides next to it. Here's the smaller side, 3. Which one do you think the 3 would match with? The 9 or the 15? And why the 9? Because it's the smaller one. And the 5, you tell me which one it matches with. See, 3 is the smallest out of these 2, 9 is the smallest, 15 is the 5 is the biggest of these 2, 15 is the biggest. Tell me the scale factor. How do you go from one triangle to the other? Times 3. Can you see it? So, the second test is 2 pairs of matching sides are in proportion. Can you see? The second triangle is 3 times bigger, and the included angle is equal. The included angle is not 3 times bigger. Remember, with similarity, the angles will always be the same, just like this. But the sides will be different. Sides will be bigger or smaller. But the angles will always be the same to preserve the shape. Okay? So the way we say this is 2 pairs of matching sides are in proportion, and their included angle, which is the angle in between them, is equal. Not some other angles equal. It has to be the angle between them so that those sides open up the right amount. Test 3 is if 2 angles. So basically, let's just go back. This is like SSS, but we have to say it in words. You got it? This is like SAS, but we have to say it in words. You're not allowed to say SAS because SAS means the angle's the same, yeah, but it means the sides are the same, and they're not. The sides are double, or they're triple, or they're half. So you're not allowed to say SAS. You have to say 2 pairs of matching sides are in the same ratio or in proportion, and the angle between them, the included angle, is equal. Now, this is a quicker way of saying it. Sides about equal angles are in proportion. If 2 angles of one triangle are respectively equal to 2 angles of another triangle, then the triangles are similar. Why am I only saying 2 angles? Let's say you've got the 60 and the 40. That adds up to 100. Doesn't the other one automatically equal 80 in both of them? That's why you don't need 3 angles. So the test number 3, it's like AAA, but we call it AA. But we just want 2 pairs of matching angles are equal, or even better, for the people that don't want to write too much, there is a great one to say. You can just use the word equiangular. All the angles are equal. So basically, but we know that similar shapes have the same angles. So this is the one that's really easy to remember. So you don't need to say, so girls, what I've got in the boxes is what you write, and you've got options. So you can just write equiangular for this one. For the one before it, you can just say sides about equal angles are in proportion. You don't have to say this big thing up here. And the first one, you just need to say 3 pairs of matching sides are in proportion. You write for your reason is in the box, not in bold. Got it? You can write this. It's only 8 words. This one, if you want to learn the quicker one, sides about equal angles. Sides about, the ones next to the equal angles are in proportion. So that's 1, 2, 3, 4, 5, 6, 7. And this one is equiangular. So no abbreviations. Now, the 4th test is like RHS, but you're not allowed to say the hypotenuse and side are equal. They're just in proportion. See, similarity is all about proportion of sides, not equal sides. So we've basically got the RHS test, but in words, and instead of saying the sides are equal, The sides are in proportion. Look, so we've got a right angle. Here is my hypotenuse. This one's 9, this one's 12. What I'm going to do, I'm just going to work out what, you know how when we do similarity, we do second object over first, or I can even do first object over second. What does 9 over 12, no, you can divide them both by 3. And so they're matching because they're both the hypotenuse. 6 and 8 are matching. What does 6/8 simplify to? So can you see that? So this is test number 4. If the hypotenuse and a second side of a right angle triangle are respectively proportional to the hypotenuse and a second side of another triangle, then the triangles are similar. This is what we write, which is what's in the box. The hypotenuse and a second side of the right angle triangles are in proportion. Okay, so not the hypotenuse and the second side are equal. The hypotenuse, it is RHS, but in proportion. So the hypotenuse and the other side are in proportion of a right angle triangle. Basically, the hypotenuse and a second side of each right angle triangle are in proportion. What are our 4 tests? The first one is like SSS, but we just say 3 pairs of matching sides in proportion. The second one is like SAS, but we just say sides about equal angles. See, the sides are surrounding the angle. Sides about equal angles are in proportion. The third one is not like any of the congruence ones. It's like AAA or AA. We just say all equal angles, equiangular. We just say equiangular. And the fourth test is like RHS. So which ones, but we say hypotenuse and second side in proportion of right angle triangles. The one that's missing is AAS. Drop the S and it becomes AA, equiangular. All right? Now, if in 2 triangles, 2 pairs of matching angles are equal, and I discussed this before, then the third pair of angles must also be equal because the angle sum of a triangle is 180. We discussed this when we looked at test 3. Therefore, in order to prove that 2 triangles are similar, it's enough to show that 2 angles are equal in each triangle. Like the 60 and the 40 in one triangle equals the 60 and the 40 in another. You don't need the 3 angles. Also, when naming similar triangles, just like in congruence, we must preserve order. If you don't preserve order, you're going to lose marks. So, for example, looking here, how do I know which side matches with this? I know they're drawn in the right orientation, but I always go, smallest side is 5. What's the smallest side in the big triangle? Okay, biggest side is 9. What's the biggest side over here? Okay, and medium side is 8. Medium side is 16. That's how I know which ones match which. So I'm going along, if I go A, B, C, aren't I going along the side with the circle and along the side with the one line underneath? Along the side with the circle, along the side with the one line, or along the shorter side, then the longer side. Shorter side, then longer side. ABC is similar to triangle XYZ. If you were to do the proof for this one, it's 3 sides, 3 pairs of matching sides in proportion. But we're going to do the proper proofs now. Girls, number 3, not. By convention, abbreviations such as SSS, SAS, AA and RHS are not used in proofs. You must put the writing. The reason is because SAS, RHS means sides are same length, not in proportion. The only one that would be acceptable would be AA because there's no AA in congruence. AA means 2 equal angles, but just use equiangular. Okay, let's start. Here is our first proof. Okay, we're looking at 4 or 5 examples here. So, example 1, prove that the triangles are similar in each of the following, hence find the value of the pronumeral. Let's go. In triangle, so remember there's 5 lines to my proof. First line is to identify the triangles. In triangle ABC and triangle CDE, angle CAB, this one, all right, you can see you've got parallel lines. Which one do you think it equals? So CAB equals angle CED. Angle CED, why do you think that is? alternate angles. Good. Don't write parallel lines. That takes too long. And why not use the notation? AB is parallel to DE. Very good. The next one, angle CBA. I'm going to go with an arc. Which one does that equal? Parallel line, zigzag, equals angle CDE. Again, you could write similarly because it's exactly the same as the line above, but I'm going alternate angles again. AB is parallel to DE. Nearly there. You could stop. We've already got two angles, but you can say the third one if you want. What else we got? Angle ACB with a cross equals ECD. Reason, vertically opposite angles. Now, I'll tell you now, you only needed two of those. You only need two angles for equiangular because by default, if two angles are the same, the third ones in both triangles will be the same. Therefore, triangle ABC is from dot arc cross. Dot arc cross is similar to triangle EDC. Please don't put congruency symbols sideways. We want similarity symbols up and down. Reason, equiangular. So equiangular. Remember, there's one of those four rules, equiangular. Now, it says, hence find the value of the pronumeral. So girls, y, so we're done there. Y is between the arc and the cross. Which one's its matching side? Girls? Y matches with 10, so y over 10. So now what I'm doing, I'm going from one triangle to the other. So I'm going from big triangle to small. So y over 10, this is what we did in year 9. So y over 10 equals what over what? Equals, so from bottom triangle to large one, matching sides. Y over 10 equals 24 over 20. Why are they matching? 24 is between the dot and the cross. 20 is between the dot and the cross. So don't swap the order. Don't go from bottom to top, top to bottom. We're not making a pattern. Bottom to top, bottom to top. Same way. If you have to, put an arrow up. Y over 10 equals 24 over 20. So what do I do now? How do I make y the subject? Times by 10, which is 12. Great. And you could see, can we, okay, all good. Next one is to find the value of x. Whatever you're finding the value of, it's best to put that first. So x matches with which one? So x over 18. Now, I wouldn't use the y that I got before. Try and use the numbers that are already there, especially if, look, y I know is a whole number and it's okay, but I prefer you to match it with the two that were already there in the first place, with the complete set. In case y was a rounded decimal, I wouldn't want you to use it. So we're going to go x over 18. So now this time we're going from top to bottom. Do you get it? X over 18 equals, this is another pair, 20 over 24. 20 and 24 are between dot cross. Equals 20 over 24. Reason, matching. So whenever you set up this similarity this statement here, this ratio statement, you must say matching sides of similar triangles in, if you don't like the word proportion, put same ratio. You know, ratio is a fraction. So you can go matching sides of similar triangles in same ratio or in proportion. So therefore x is 20 over 24 times 18, which is 15. Excellent.